Right, Sigu? You can prepare. And a little bit about Sigu, community lover, software writer, team builder, and passionate human who loves promoting software quality, improving the development process, and building highly scalable system and teams. Sigu is a father to many and husband to one, fell in love with Ruby, but ended up marrying Elixir after dating shortly. In his dream career, he would be driving an 18-wheeler across the continent. All right, very nice introduction by Sigu. Thank you for joining us today, and the stage is yours.
All right. Thank you. Can you hear me? Can you hear me? Just let me know if you can hear
Hear
me.
you?
Awesome.
Yeah, I believe you can hear.
All right. You've done a very great introduction of me. I don't think I'll do a better job than that. Am I the person who wrote that for you? Yeah. Um, wow. I'm reintroducing myself despite being introduced. So I'm a teacher. I love teaching, and you might see some of that from the presentation I'm just about to do. I've lost my screen share. Yep. Thank you. Yeah. I love writing code, so I spend as much as time possible to write code, mostly in Elixir. I also love the community. It's 8 p.m. right now, almost 9 p.m. But yeah, we're here doing the community things. I also run Elixir Kenya, Elixir Safari. I'll talk about that towards the end. I run a consulting firm called Podi, and we do work with web and mobile applications. We specialize in Elixir and do staff augmentation to people who need it. Let me head straight to sharing my other live book. All right, here you go. Am I there? Yes. So let's step back from what Alvaro just talked about. So it's time to rewind and just start over from the beginning. All right. Let's talk about processes in Elixir. The smallest possible process that Alvaro was talking about. You can create a function in Elixir, an anonymous function. So you can create this anonymous function. It's usually called, what am I forgetting? Yeah, we can call it an anonymous function. It's called query. It sleeps for 5 seconds, then displays a result. So let's evaluate that. So these are the basics of how Elixir works. Evaluate that, then when we run the function called run query, it takes about 5 seconds. Have a look at this. So it takes about 5 seconds, then it displays the result. I hope you're together to that, up to that point. So we can take 5 of these and run them. So let's run this 5 times. So we map over 1, 2, 3, 4, 5 and run it 5 times. So let's evaluate that and then we wait. Dun, dun, dun. So each and every time it's going to take 5 seconds to run the first one, 5 seconds to run the second one, 5 seconds to run the third one. So I hope you can guess how long this is going to take. It's going to be about 25 seconds. So we have about 7 more seconds remaining for us to evaluate this. Yep, done. So it takes about 25 seconds to do 5 of these. So this is a problem that we have to solve, and Elixir solves it very nicely. I can call them minions, so you can spawn up some minions and just take them out there to do some work. So just bless the minions, put them out there to start doing some work. So you can spawn something, and when you're spawning, you can take in a lambda, then it does what it does, then it dies immediately after that. All right. So in that case, we can repeat the same thing that we had over here, but now instead of having it sequentially calling one at a time, we bless the minions, get all the minions out there to do their work, and it's going to give us a result after yeah, that was too fast. So it checks out immediately after doing all that. I'm using something called Livebook, and Livebook can allow us to do some diagrams. So I'll be able to show you the diagram of what just happened. If I comment that out and I reevaluate, I need to zoom in. I might need to zoom in and hide this. Hide. Awesome. So the current process that is running, which is in the live book, is called self. So self is going to spawn. To spawn is to create, it's to bless a minion right here. So spawn. That's what's happening right here. So you spawn one function, let it run. You spawn the next one, let it run. Spawn the third one, let it run. You do that 5 times. Then you just let it go and do whatever it is it can do. Then after doing that, it's going to set you free to continue doing whatever it is. But now the problem with this is that we're not in any position to get back the result. We are not in any position to communicate between the minions. They are not able to talk. Once they're out, they're out. They're going to do their thing. They're going to die without even being able to give us back our results. I hope you're to get up to that point. So how really do we solve the inter-process communication? How can we make it possible so that a result from one minion can be sent back to the parent or can be sent to another minion, just so that we can be able to have these two things together, or 3 or 4 or as many as we want? That can be done by, you can guess it, you can just send it, then maybe receive it. Yeah, exactly. So Elixir allows you to send things and receive them. It's deep down in Erlang, but today we're talking about Elixir. So what we are doing at this point is that we are spawning a child and we are letting the child receive something called ping. And if it receives a ping, it's going to send something to the parent. So this is a child, you're spawning within the parent. The parent is the live book process. It sends to the parent something called pong. It's just sending you a message pong. All right. Then the parent calls the child, giving it a ping. Then when it receives a ping, it talks back to the child. I'll uncomment that just so that we can visualize that. Evaluate. Perfect. So this is what just happened. Live view, which is self, a live book, sorry, spawned a process. So the PID is 353. It just spawned that. Awesome. After spawning it, it sends it a ping. Info ping. Once it sends this a ping, this will receive the ping. If it receives the ping, then it's going to send back to the parent a pong. So it sends back to the parent a pong. The parent is the self. Great up to that point. So you just give it the address to whoever you want to send it to. All the messages will be there, fast in, fast out. If you send a message that cannot match, let's say pang. Let's try pang. Evaluate. Ooh, what's happening? Yeah, it's still running. So it's waiting for a message to come through that it can match. So you can see it's still running. So it hasn't received anything. It's not going to respond. It sent the parent a pang, and the parent is still waiting to respond. So you can stop that, take that, pong. All right, so let's create a server. Don't call it a gen server. Let's just call it a server. And we're calling it a server because it runs for infinity. It just never ends. So this is how our server works. Let's call our server calculator. Thank you, Sasha Yurik. I've just gotten this from Elixir in action. So what this does, it's a calculator. It has a function called start, which spawns a process. All right, spawns a process. This process calls a loop. What does loop do? Ooh, doop, doop. Down here, yeah, loop receives. So it waits to receive, then it calls itself. So wow, this is a tail recursion. So loop calls loop. So this never ends. All right. So if it receives something, it acts on it, then it calls itself. Receives, acts on it, calls itself. It just never ends. So it's like an always listening server to something to happen. So the ability of this server is to process a message, and in processing a message, you can pattern match. So you can say you're processing a message, give it the current value. If it's value that you want, then it's going to send you back the value. If you're adding, then it's going to add. If you're subtracting, then it's going to subtract. If you are multiplying, then it's going to multiply. Okay. So let's do this. Kino process, then we can render the sequence diagram. Now, the first thing that we need to do is to start this. So we call calculator.start, which will get us into a loop. After we get into that loop, we can call add 2, then we can add 7. Let's try this. Let's try this and hope it doesn't fail. Of course, it's queued, which means there's another process that is running. I hope it's not the top one. Yes, it is the top one. So let me just reduce the time on this one. Yeah, so it's spending a lot of time running this. I might just have to comment this out. I'll have to wait for 25 seconds. Yeah, it just happened. Let's do this again. Where were we? We were right here. Do this again. Evaluate. Awesome. So we just created called start. So self did a spawn. It spawned something with PID 510. That happened right here. Then it called add, which we did here. Then we did another add, which is here. Let's do something. Let's just add an extra add. Let's add 217. All evaluate. Yeah. So for every add that you do, it sends to the child. It just tells it to add. What if we multiply? Oh, typo, multiply. Try that again, reevaluate. Yeah, so it multiplies. What if we try to get the value? We should do that by, what was the function again? Value. Just call the value and give it the ID. File, give it the ID. Call it again. Reevaluate. Ooh, something happened. Calculator is not something. Oh, 1 is not, it should be value. Reevaluate. Are we there? Yes, we're there. Perfect. So we call add, multiply, then we request for the value and we get back a response. So we're getting back a response because we have a send here. That's why we're getting back a response back to the self. I really hope we are together up to this point because we are leading to a Gen server as we're moving. All right. So let's create another calculator and just see how this works. Let's create another calculator, start another process, and let's call this calc2 PID. Then we can call add on calc2. So this needs to be calc2 PID. So we send this specifically to calc2, which we have just started. We can multiply. Multiply. Yeah, 2. That's fine. Rerun. Yes, that worked. So we spawned the first one. Then we spawned another one. We spawned the first one, called add, multiply, requested for the value, got a response. We spawned the second one, called add, called multiply. So this is a sequential diagram of exactly what happens when you do this. Let's jump to the next one. Now, karibu sana kwa GenServer, karibu is Swahili for welcome. So now let's welcome the GenServer world. We'd taken a lot of steps back from where Alvaro was. Now we are at par with Alvaro. So I'll not go into the detail as to the callbacks. I'll just explain what we do have in the GenServer. So from what we had before, it's a lot of boilerplate that we might have to write for ourselves. All this, starting a server, reacting to it when it happens. So this was so common that a common interface, which is a behavior, was created, and it's called a GenServer. So a GenServer allows you to start something that runs infinitely and react to events whenever they happen. You had seen this before in Alvaro's presentation, but yeah, it allows you to start and it runs infinitely. It allows you to interact with this by doing what we call the cast. We do the call, no detail into this. Once you do the cast, you can handle the cast and you can handle the calls. So let's have a little bit more fun by visualizing this again. Perfect. GenServer. Perfect. So our self is spawning something called stack. Now it's no longer the gibberish. It now has a name. So it just spawned something called stack. Then after that, stack told it that, yeah, I'm up. I'm acknowledging that things are fine. Then we push, 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 pop. That's the push, 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 pop. Right here. Okay. So this is now a GenServer that we didn't have to write all the boilerplate code. We just had to start it and call things directly into it. GenServers also allow you to inspect their state because they maintain some internal state in them. So we can call system trace to find out what really is happening and reevaluate this. He already started. So let's just reconnect this and let me hope this is not going to take long. Reevaluate. Perfect. So if you trace your GenServer, which you started here, it's going to tell you exactly which messages are being sent. So the GenServer got cast, so it pushed 900 right here. So it has a new state 900. It got a cast, which is push. It pushed 800. So the new state is 800 and 900, the 900 we had before. We again pushed 700. So it pushed 700. Now it has 700, 800, 900. Push 600, 600. So that's what we have right here. Then at this point, we called a pop right here. It popped and it now has a new state 700, 800, 900. The 600 is gone. These are the different. We had stack, but now we have different other processes, and those processes enable us to trace. That's why they're up. We can get the state of our current GenServer by calling the get state, then reevaluate. Yeah, yes, it's already started, so reconnect, then reevaluate. Yes, awesome. Looks complicated, but our current state now does not have 600. All right, so let me uncomment this and show you something cool about the keynotes. And comment above and rerun this. Yes. Next week, you're going to learn about supervisory tree. So once you get there, if you attend that particular meetup, it's going to cover more about how supervisors work. But right here, we are starting a supervisor and telling it to start the stack, which we had defined up there, which is our GenServer. We have a task, which Alvaro talked about, and an agent. So we have three things which are being started under the supervisor. So to give you a visualization of exactly what's happening here, we can evaluate. No, I have to reconnect. Then after reconnecting, I'll have to evaluate again. Perfect. So now we have this, which started the stack. One of these is the task, and the other one is the agent. So this is supervising these three. We just told it to supervise the three. More details are to the strategy and the children and child spec, I think that's going to be discussed next week. The aim of the talk that I'm doing today, or I did today, was to make you understand why GenServers exist in the first place, what really motivated this to exist, and how they came about. I love teaching, so I love using graphics to show, at least so that it can stick. I hope you enjoyed this, and I really hope you have a little information about GenServers, but you're not now a pro in it. Asante sana, which means thank you in Swahili. Thank you so much. I'll open it up for Q&A.
Asante San as well. So if you have any questions for Sigu, just write them down. I believe that was a great presentation because especially using Livebook for visualizing stuff is really cool. And I think this feature by Keynote that you can visualize the flow of the messages that being passed is really helpful to demonstrate what you showed. All right, so far we don't have much questions, but maybe they'll show up very soon.
Yeah, we do have what we call Elixir Safari in June this year. So that's what I have up. It's an Elixir conference with a mix of a safari.
Nice. Is it in Kenya or is
Yes,
it?
it's in Kenya, Nairobi, Kenya.
All right, nice.
Yeah.
Are you going to a safari after that?
Yes. So we're going to have trainings on Wednesday. Thursday and Friday is going to be a conference. Then Saturday and Sunday is going to be the safari. We're going to do game drive, visit to the tea farms. We're going to do elephant orphanage, the giraffe centers. So that's the current itinerary as is.
Nice.
Yes.
I've been in safari in Tanzania last year, so I believe you're gonna have a great time.
Thank you.
All right, so just a
I
moment.
can see some questions on the public chat.
Yes, I'm opening the Q&A. All right. Here's the first one.
Yes. Why spawns are yes, you got it right. Tasks are spawns, GenServers are. So what happens is if you spawn, you lose it. It's hard to keep track of. So this is just a minion that you send out into the wild to go do the job. So if you need the minion to give you something back or tell you something in return, you can do a task that you can supervise. So you can just sit and look at how many people you have sent out, tell them exactly what to do and when to do it. So the next layer of wrapping of a task of a spawn should be something like a task, if that makes sense. Then GenServers are mostly for very long running processes. Tasks are not really meant for long running processes. And I've just remembered the bottleneck for GenServers that was asked previously. One bottleneck I ever did without knowing was um, for every web request that was coming through, I was doing my calculations of the Gen server before saving to the database. So I literally created a bottleneck, and not a lot of things would come, not a lot of things would be concurrent because they all had to go through the Gen server. So as much as there was concurrency, everything had to go through the Gen server, wait for it to be, then try to be concurrent again. So there was a lot of drop in the performance.
Okay, for now we don't have another question.
Okay.
Do you feel like you often have to write some GenServers in a typical web application? Like, do you feel like this is something that you'll have to implement every week or something like this? Because yeah, in typical scenario, I feel like this is, let's say, something to be done once at 2 months or something like this in a normal project, because of the fact that most of the stuff that Phoenix comes with already contains a lot of GenServers that are being done for you. Do you feel the same way, or?
Yes, I agree on that. It's not easy for you to come up with a use case for a Gen server all the time, unless it's a new project. Then you might have to do a few Gen servers here and there. Then once you start having Gen servers in your project, you might not really need to have more Gen servers on that particular project because it's there to handle maybe recurrent and long running processes, which if it gets too much or it runs for too long, then we have other Gen stage etc to handle such. So Gen servers are again an intermediary between the not so long and not so bulky and the very bulky where Gen state and etc. Not Gen state, how do you call it? I keep forgetting this. Yeah, the one that handles bulk processes.
Yeah, in the pipe, or what do you mean?
Yes. It's if you have more than, let's say you have you're dealing with things like buffers that has more than like a million things to be processed, a Gen server would not be a great idea to work with in that case.
Yeah, I think you're referring to Gen stage.
Yeah, it's Gen stage, yes.
Yeah.
Yeah.
All right. There are some comments, but I'm not sure if these are the questions. These are just the comments, I believe. All right. Okay. So maybe Sigu, you can share the link to Elixir Conf as well on the chat. So maybe someone will attend the conference. That would be incredible. And I'll also, thank you. I'll also share the links to our community after the presentation, and you can also visit Poddy because I added a button on top of the presentation where you can check Sigu page. Okay, thank you, Sigu, very much, especially because of it's very late for you already in Africa. Thank you for the presentation. Presentation will publish the presentation on our YouTube channel in a couple of days. And for all of the attendants, I have a small survey after the presentation. If you have some spare time, you can also help us improve the meetups. Thank you very much, everyone, and see you on the next meetup. Bye-bye.
Bye. Bye-bye. Thank you.